Lesson 30 is on repeating decimals, and repeating decimals look like a decimal that continues on forever, but it's repetitive. So for instance, if I take the fraction 1/3 and I convert it to a decimal, it becomes the decimal 0.3333, repeating. And the way that we write a repeating decimal, rather than just keep writing threes, we put a line over the decimals or the numbers that repeat. Another example of one where not all of the decimals repeat is 1/6 is the decimal 0.16666 repeating. So the 1 doesn't repeat, but the 6's do. So we would write that as 0.16 with a bar above the 6, not the 1. The bar represents the numbers that repeat. It can also be multiple numbers. For instance, if I have the fraction 27/99, that's the fraction, or the decimal 0.272727. So the 27 repeats, so we could call that 0.27 with a line above the 2 and the 7. Number 1, there are 20 students in the algebra class. 1/2 of the students were boys. 1/2 of the boys wore t-shirts. How many boys wore t-shirts to the algebra class? So if I have 20 students are in the algebra class, so I start with 20 students. If half are boys, then I divide 20 by 2, and I get 10 boys, and then half of the boys are wearing t-shirts, so then I have 5 boys in t-shirts, because that's half of 10. How many boys wore t-shirts to the algebra class? So there were 5 boys in t-shirts. And then the second question asks, boys wearing t-shirts were what fraction of the students in the class? So there are 5 boys wearing t-shirts and 20 total students. So 5 out of 20 reduces to, well, both of them can be divided by 5. So I have 1/4 of all the students were boys wearing t-shirts. The big room measured 19 feet 10 inches by 22 feet 1 inches. About how many square feet of carpet are needed to recarpet the big room? So when it says the word about, that means we're going to estimate, so we're going to round. And 19 feet 10 inches is closest to 20 feet, because 10 inches is just 2 inches away from the next foot. So we have 20 feet by 22 feet 1 inches is closest to 22 feet. So if I'm going to find how many square feet of carpet, they're asking me to find the area of the room. And so I have a rectangle that's 22 feet by 20 feet. 22 times 20 is 20 times 20 is 400. And then 20 times 2 is 40. So we have 400 plus 40. So 22 times 20 must be 440 feet squared. That's why they say square feet of carpet. The 4 pencils in Julio's desk have these lengths: 7.5 inches, 5 3/4 inches, 5 inches, and 2 3/4 inches. what is the average length of the 4 pencils? So to find the average length, we need to add them all up and then divide by how many there are. So I'm going to add 7.5 plus 5 3/4 plus 5 plus 2 3/4. And the way that I like to add mixed numbers is I just take and I add all the whole numbers first, and then I deal with the fractions in the end. So 7 plus 5 is 12, plus 5 is 17, plus 2 is 19. And then I have the fractions, 1/2 plus 3/4 plus 3/4. In order to add fractions, I need to have them all have the same denominator. Both 3/4 do, but I need to have the 1/2 also. So I'm going to say that 1/2 is equal to something over 4. To go from 2 to 4, I multiply by 2. Whatever I do to the bottom, I do to the top. 1 times 2 is 2. So that means that I have 19 plus 2/4 plus 3/4 plus 3/4. So we add the numerators. 2 plus 3 plus 3 is 8. And 8/4 reduces to 2 because 8 divided by 4 is 2. So that becomes 19 plus 2, which is 21. Okay, so the adding up all of the lengths of pencils is 21 inches. And now we have 4 pencils. So we're going to take 21 divided by 4 to get the average. And 20 divided by 4 is 5. And then 1 divided by 4 is 1/4. So 5.25, or 5 1/4. Is the average length of the pencils on his desk. You could also do the division the long way like this. And you would say 4 goes into 21 5 times. 5 times 4 is 20. 21 minus 20 is 1. And we put the decimal point and a 0. 4 goes into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. Bring another 0 down. And then 4 goes into 20 5 times. And once we get 0 for our remainder, we know we're done. Find the area of the triangle. The dimensions are in millimeters. So in this one, it's kind of weird because the base and the height, remember, of a triangle when you're finding the area need to be perpendicular. So we can't just use this 5 and this 5 because this angle right here is not a right angle. So in a triangle like this, we actually draw out a line from the base like this to the edge of the top point of the triangle, and we make it perpendicular. So now our base is still 5, but our height is 4, not 5. So to figure out area of a triangle, the formula is 1/2 the base times the height. So we have 1/2 the base, which is 5, times the height, which is 4. 5 times 4 is 20. Half of 20 is 10. And it said that the units were in millimeters, so if we're talking area, it would be millimeters squared. Classify the triangle in problem 4 by angles and sides. If each acute angle measures 26.5 degrees, then what is the measure of the obtuse angle? So by angles, we look here, and they already told us here what's the measure of the obtuse angle. Since this angle right here is more than 90 degrees, by angles, this triangle is an obtuse triangle because it has an obtuse angle. And then by sides, we have two equal sides. The other one is not, so it is a isosceles triangle. Then it says if both of these angles here, and here are 26.5 degrees, what's the obtuse angle measure? Well, if I add up 26.5 plus 26.5, 26 and 26 is 52, and then a half is 1. So that's 53 total degrees being taken up by those angles. And there are 180 total degrees in a triangle. So I subtract off 53. So 53 plus 7 would give me 60. And then I have 120 more to go. So 127 degrees. The $80 DVD player is on sale for 25% off. Find 25% of 80. Well, the easiest way to think of this is 25% as a fraction is 1/4. So 1/4 of 80 means 80 divided by 4. And 80 divided by 4 is 20. What is the ratio of a side length to the perimeter of a square? Well, if I have a square, and let's say each side length is 2. Actually, let's start with 1. That one will be even easier. So if I have a square, and each side is 1, let's say foot, then the perimeter is 1 plus 1 plus 1 plus 1, which is 4, and a side length is 1. So it's asking the ratio of side length to perimeter. So we put the side length first. And then the perimeter. So the ratio is 1/4. And we can test and see if that's true for all of them. So let's say we start instead with a triangle that, or a rectangle that has side lengths that are 2. And the perimeter is 2, 4, 6, 8, and a side length is 2. So the ratio of side length to perimeter is 2/8, and that would reduce to 1/4. So it looks like it's true, no matter what the side is. In number 8, we have both adding and multiplying fractions, so we need to first use order of operations, and order of operations says that multiplication comes before addition and subtraction. So first I'm going to do 2/3 times 1/2, and since I have 2 and 2 diagonal, I can divide them both by 2. 2 divided by 2 is 1. So then I end up with 1/4, since I haven't done anything with that. And then 1 times 1 is 1, and 3 times 1 is 3. Then, to add those two fractions, I need to find a common denominator, and the common denominator for 4 and 3 is 12. So if I rewrite 1/4 as something over 12, to go from 4 to 12, I multiply by 3. Whatever I do on the bottom, I do to the top. So 1 times 3 is 3. So 1/4 I will rewrite as 3/12. And then I need to write 1/3 as something over 12. To go from 3 to 12, I multiply by 4. Whatever I do to the bottom, I do to the top. 1 times 4 is 4. So I will write 1/3 as 4/12. And then 3/4 plus 4/12. 3 plus 4 is 7. Keep the bottom the same. Is 7/12. Again, I have order of operations with my fractions, and division comes before subtraction, so I'm going to do that first. When you divide a fraction, you multiply by its reciprocal, which means you flip those around. So 7/8 minus 1/8 times the reciprocal of 1/4 is 4/1. 4, and I'm going to leave it that way. So now I'm going to do 1 times 4 is 4. 8 times 1 is 8. So this here turns into 4/8. And I chose not to reduce right away because I saw that I would need to subtract, and I wanted to keep the denominator as an 8. So now 7/8 minus 4/8. 7 minus 4 is 3, and when we keep the 8 the same, so 3/8. When we have things being added in either the numerator or the denominator of a fraction, it's like there's parentheses around those, and we do those first. So we're going to do 1.23 plus 0.4 plus 5. Then we can put in zeros for placeholders. Adding those up, 3 plus 0 plus 0 is 3. 2 plus 4 plus 0 is 6. Put our decimal there. 1 plus 0 plus 5 is 6. So the top becomes 6.63, and the bottom stays 0.3. So we have 6.63 divided by 0.3. And when we have the divisor being a decimal, we need to move the decimal point over. So our problem becomes 66.3 divided by 3. So our decimal point will be here now. 3 goes into 6 2 times. 2 times 3 is 6. 6 minus 6 is 0. Bring the 6 down. 3 goes into 6 2 times. 2 times 3 is 6. 6 minus 6 is 0. Bring the 3 down. 3 goes into 3 once. 1 times 3 is 3. And we have no more numbers, and our remainder is 0, so we know we're done. So 6.63 divided by 0.3 is 22.1. I'm going to move this one over so it's not overlapped for the next one. In number 11, we have all sorts of different orders of operations happening. So please excuse my dear Aunt Sally. There's no parentheses, so we move on to exponents, and we have 2 of them. So 4 to the 0, anything to the 0 power is 1. So 4 to the 0 power is 1. And then 1 to the 3rd power, 1 to any power is 1. After exponents, we do multiplication and division, and we work from left to right. So 4 times 5 is 20, times 2 is 40. So we have 1 plus 40 minus 1. And then we do addition and subtraction, and we work our way from left to right. 1 plus 40 is 41, minus 1 is 40. In number 12, we have order of operations again. We have all sorts of sets of parentheses. So first we would look inside these brackets, and then we'd start over with please excuse my dear Aunt Sally. So we have another set of parentheses in here. And then we would start off with please excuse my dear Aunt Sally again. And the first thing that we would do is this exponent here. So 0.2 squared means 0.2 times 0.2, and we just do, we ignore that they're decimals, so we would do 2 times 2, which is 4. And then we have 1, 2 decimal places, so we go 1, 2 places over. So 0.2 squared is 0.04. So we have 0.8 minus 0.6 minus 0.4 minus 0.04. Once the only thing left in that bracket is 0.4 minus 0.4, we can do that next. So we have 0.4 minus 0.04. So we just do this like regular. So it's basically 40 minus 4, which is 36. So 0.36 can replace that underlined portion. Now we have 0.6 minus 0.36, and 60 minus 36 is 24, so it'll be 0.24. So then we have 0.8 minus 0.24. Now we've gotten rid of all of the parentheses and brackets. So then we have 0.8 minus 0.24, and 80 minus 24 would be 56. So my final answer is 0.56. 13 says write 2/9 as a decimal and a percent. So the first thing that you need to do is get it into decimal form. And the way that you write a decimal or a fraction, turn it into a decimal, is you divide the numerator by the denominator. So we have 2 divided by 9. 9 can't go into 2, so we add a decimal point. And now the question is, how many times does 9 go into 20? Goes into 20 2 times. 2 times 9 is 18. 20 minus 18 is 2. And then I'd put another 0 up, but then I have 0 again. So I have 20, which would be 2. 2 times 9 is 18, and I'd end up with 2 again. So I'm noticing that this is going to be a repeating decimal. So 2/9 is going to be 0.2 repeating. So to write that as a percent, I would say, well, I have this decimal 0.2222 repeating. To turn a decimal into a percent, I go from the decimal point, I move it 2 places to the right. So I would have 22.2 repeating percent. So I now have 3 ways to write 2/9. 2/9 equals 0.2 repeating equals 22.2 repeating percent. Which of the 3 forms is the most convenient for finding 2/9 of 27? The fraction is the most convenient because, first of all, it's something that you could actually type into a calculator. It's accurate. Anything that you would do with a repeating decimal like this, you would actually have to round it to type something into a calculator. And actually for 2/9, you don't have to write it in, put it in a calculator, because you know that 2/9 of 27 means 27 divided by 9 times 2. Well, 27 divided by 9 is 3, times 2 is 6. So 2/9 is the easier way. Write 70% as a decimal and a fraction. Well, 70%, to take a percent and write it as a decimal, you would take the decimal point, which is here if it's not shown, and you would move it 1, 2 places to the left this time. So as a decimal, 70% is 0.7. I could put a 0 at the end, but it doesn't really need to be there. And as a fraction, since this is in the tenths place, then that means that it is 7/10 as a fraction. In number 15, it says plot these points and find the area and perimeter of the rectangle with these vertices. 5, 11. So I'm going to call each one 2. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. Otherwise, my graph would go off, and it would be hard to count because there's 11, and there's only 10 spaces on this particular graph. So, if I have 5, 11, 5 would be halfway between 4 and 6. And then 11 would be halfway between 10 and 12. That would be there. And then 5, 1. So 5 again is halfway between 4 and 6. 1 is halfway between 0 and 2. And again, if you have your own graph paper or you're making your own graph, you don't have to count by twos. In fact, it might be easier for you not to. I just wanted to make sure mine stayed on the graph. And then negative 2, 1. So negative 2 and then halfway up, and then negative 2, 11. So we have this is our rectangle, which kind of goes across my numbers, but that's all right. So if I'm up here at 11 and I go down to 1, 11 minus 1 means that this side length is 10 units. And if I'm over here at negative 2, and over here at 5, 5 minus negative 2 means 7. It's a distance of 7 between those on a number line. So this side is 7 units. So I have a rectangle, and I'll just sketch it over here quickly. That's 7 by 10 units. And if I want to find the area, well, I'll start with, area. The base, the length times the width. So 7 times 10 is 70 and units squared, since it's area. And then the perimeter, I add them up. 7 plus 10 plus 7 plus 10. 10 plus 10 is 20, and 7 plus 7 is 14. 20 and 14 is 34. So 34 units. In 16a, it says expand, and that basically means use the distributive property. So this 5 gets multiplied by each thing inside the parentheses. Whoops, that goes to the z, not the plus sign. So, and the symbols in between them stay the same. So I have 5 times x plus 5 times y plus 5 times z. And that's it. And then, if I'm going to factor, I look and I say, well, kind of like in this A where there was a 5 for each, and then that's what was outside, what is the same between all the things separated by plus signs? Well, there's a W in each. So that W is going to take the place that the 5 was in 16. So W, and then in parentheses, once I get rid of the W, I have x plus y. And I could test it out. If I did the distributive property through, I'd have W times x plus W times y, which is what I started with. Simplify. I have x to the 5th times x squared. So I have x to the 5 plus 2 power. And then x down here, since there's no power, it's a 1. So I have x to the 7th over x to the 1st. And when I divide, I subtract the exponents. So I have x to the 7 minus 1 power, which is x to the 6th. And if you want to see how that works, the top would be x times x times x times x times x, 5 of them, and then 2 more for x squared. and then the bottom would be just x. And since I have one here and here, they would cancel out, and then I'd have 1, 2, 3, 4, 5, 6 x's left, which is x to the 6th. Write 28,000 in scientific notation, or 28 million, excuse me. So for scientific notation, I have to have the decimal point be one spot. I get one non-zero number to the left of the decimal point, and then I count how many places did I move the decimal point. 1, 2, 3, 4, 5, 6, 7. So times 10 to the 7th, how many places I moved it. Write the prime factorization of 1 million using exponents. Well, I know that 1 million is going to be 10 times 10 times 10 times 10 times 10 times 10. So I'm going to have 10 to the 6th. So that's not going to be prime. So it's going to look like this, 10 to the 6th. But 10 is not a prime number. The prime factorization for 10 is 5 times 2. I'm just going to replace this 10 with 5 times 2 to the 6th. And then when I have parentheses around numbers and I have an exponent on the outside, the exponent goes for each of them. So I would have 5 to the 6th times 2 to the 6th. Compare 169, the square root of that. That's one that you should just know. The square root of 169 is 13, or 13 squared is 169. And then 3.7 squared. So 3.7 times 3.7 would be 37 times 37. 7 times 7 is 9. 49. 7 times 3 is 21, plus 4 is 25. Put my 0. 3 times 7 is 21. 3 times 3 is 9, plus 2 is 11. And then 9 plus 0 is 9. 5 plus 1 is 6. 2 plus 1 is 3. And 1 plus 0 is 1. So I have 1, 3, 6, 9, and I ignored 2 decimal places. So I put the decimal there. So this is 13.69. So 3.7 squared is larger. Which property is illustrated below? So it looks like I have just switched the order of this and this. And switching the order is the commutative property. And in this case, it's of multiplication. And then in B, they've switched where the parentheses are. And switching the order or the position of parentheses is the associative property. Arrange in order from least to greatest. So I have 2/5, which as a decimal is 0.4. And I know that because 2/5 I could turn into something over 10. To go from 5 to 10, I'd multiply by 2, so I'd multiply by 2 up here and get 4. 4/10 is the decimal, 0.4. 35% as a decimal, I move the decimal place over 2 places, so it's 0.35. And now I can compare. So none of them are negative, so I start with 0. And then the smallest one is 0.3, because 0.3 would be 0.30, and 0 is less than 5 here. So I'd have 0.3, and then 0.35, and then 0.4, and then 1. Classify this triangle by side length and angle measure. Well, each of these marks means that it's a different length. So since none of the sides are the same length, this is called a scalene triangle. And all of the angles appear to be less than 90 degrees, so this would be an acute triangle. Solve by inspection, which means what do you do, what number does the letter have to be to make the equation work? So 2.2 equals 2 plus 0.2. Well, if I'm going to add something on to 0.2 and have it be 2.2, it has to be 2. So 2 times what number still gives me 2, and would have to be 1. So we check it out. 2 times 1 plus 0.2 is 2 plus 0.2, which is 2.2. So that one works. So 4/5 is 1 minus r. So if I think of this 1 in terms of fifths, since that's what it's going to end up being, it would be 5/5 minus something over 5. 5/5 minus what would give me 4/5? Well, 5/5 minus 1/5 would give me 4/5, because 5 minus 1 would be 4 over 5. So r must be 1/5. And I already checked it up there. 7 over 20 equals 7 over 10 times a number. Well, if the two numerators stay the same, then I know that h must have a 1 in the numerator. And then it looks like the denominator was multiplied by 2. So h must be 1/2. So if we check, is 7/10 times 1/2. 7 times 1 is 7, 10 times 2 is 20. So that works. T plus 3 divided by 4 is 5. So we need to think this number here, what divided by 4 would give me 5? Well, 20 divided by 4 would give me 5, so 20 has to be whatever t plus 3 is. So now, what number plus 3 gives me 20? T would be 17. So we check it out. 17 plus 3 divided by 4. 17 plus 3 is 20. Divided by 4 is 5. That one works. 28. Find b squared minus 4ac when a is 4, b is 9, and c is 5. So b squared is 9 squared minus 4 times a is 4 times c is 5. 9 squared is 81. 4 times 4 is 16. And 16 times 5 would be 80. 5 times 10 is 50. 5 times 6 is 30. 50 and 30 is 80. So b squared minus 4ac is 1 in that case. Suspended objects such as apples in a tree or hailstones in a cloud have potential energy equal to their mass, m, times the acceleration of gravity, g, times their height, h. For the equation mgh, E equals mgh, find E when m equals 2, g equals 9.8, and h equals 5. And this has a lot of words. Really, the only thing that you need to know is there's an equation, E equals mgh, and they want us to find it with these specific numbers. So we have m is 2, g is 9.8, and h is 5. Now looking at these numbers, I would like to be able to get rid of this decimal here. And I can see that if I take the 2 and the 5 and multiply them first, I get 10. And when I multiply decimals by 10, I move the decimal point. So I'm going to reorder this by the commutative property and say that this is 2 times 5 times 9.8. 2 times 5 is 10 times 9.8, and 10 times 9.8 takes the decimal point and moves it that way one place. So 10 times 9.8 is 98. And it doesn't tell us what the units are. So we'll just say units. Probably kilograms. Oh no, joules. In the figure, AC is 1 unit. BC is 2 units. And use the Pythagorean theorem to find AB. So we'll call that C. Since we have the 2 legs, A squared plus B squared equals C squared. A squared we'll call side BC, so we'll have 2 squared plus 1 squared. 2 squared is 4. 1 squared is 1. 4 plus 1 is 5. So to find just C, we take the square root of both sides. So the square root of 5 is equal to C. Now, we don't need to find the actual answer for the square root of 5. It's not going to be a pretty number. It's going to be an irrational number, which means it's a decimal that does not end and does not repeat. But we do know that it's going to be a little bit more than 2, because the square root of 4 would be 2, and this is just more than 4. So the length of AB is 5. Square root of 5.